to my another video. It's me, Sachin Jaiswal. Today we are going to make a 150 Ah lead acid battery replacement with the use of these 6000 mAh Lifepo4 or lithium iron phosphate cell using a 100 Ah BMS. So it's a 100 Ah BMS. So what we are going to do today, it's we are tested all these batteries. These are at around 3.27 and 3.28 volts every cell. So just because these are new cells, so we are not going to balance them, and I will really want to thank all my buyers, all my purchasers, and all the viewers who have created the community, and those who have brought for me and who has purchased the batteries from JCSUPER. So let's get started and create this 150 Ah battery bank. And yes, and this the whole battery bank will be cost about 19,000 rupees, so you can go for it. If you want to replace a new lead acid battery, then people's first choice will be this. So let's get started. So first, what we are going to do, we are going to create a batch of 25, 5 and 5. In this we are going to add all the plus together and all the minus together. 25 cells, 25 cells, 25 and 25. So we are going to make a 4S. So let's start. First of all, we have to scratch all the terminals as I always do. In about 45 minutes to scratch all the terminals plus and minus of all the 100 cells. You can see we have scratched with the help of plier or wire stripper. So now what we are going to do, we are going to add all the terminals with the help of soldering iron. We have to add a soldering on the top and the bottom of each cell. But before that, what we are going to do, we are going to add these blocks like every 25 cells. Wait a second, I will come back. Like this, we have added the original cardboard spacers in between all the cells. Okay, and likewise we will make a bunch of 4. Okay, first one is like this, and this one will be flipped, this one is like the same, and this one will be flipped. So we will connect this to minus, and likewise I will explain in my further video. So let's first of all add some cellophane so that we can tighten this. Here's the cellophane wrap. So we will take it like this. It will take some effort. So first of all, let me wrap once, then the second time it will be perfect. So, like this. Okay, and now with some strikely we have to stretch it as far as we can, so it will tighten itself. check it first properly. The cells which are moving here and there, it will be rectified once all sold. So it is done now. So we will make all the 4 like the same. Okay, we'll do all the red cell like bunch of 25 and then add the soldering wire. You guys can see we have created 4 bunches of 25 cells each. So what we are going to do, we are going to take this like this side, second one as opposite, third one like this, and last one like this, and then we will joint in like plus goes to minus, all goes like this, and then the opposite side plus goes to opposite side minus, and then this one comes to this side, and we will get positive and negative on the other side. So keep watching. What we are going to do, we are going to add flux to all the terminals. So we are using the 60-watt solder. So let's get started. Just do not wait for so much time. Like this. Just because we have already scratched the surface, soldering will pick the surface easily. You can see. So likewise, we have to add all the terminals with the flux. We have added all the plus and minus terminals to the flux, or you can say soldering. We have already added. You can see the terminals are properly added the flux, so that we can start adding the wires to it. So now we will peel it. Started soldering with the help of wires. So we are going from this to series, from this bunch to this bunch. You can see we are adding like these spirals. So what we are going to do, we are taking a bunch of wires and stripping the cover and adding the soldering flux on the wires like this. It will help the wire not to get the carbon over the ears and will help flow the amperes easily. And just add like this. You can see it is added. Next one like this, it is added, and we will go further. Here you can see we have joined these two in series, and we have left a space in behind so that we can flip it over. So before we have added some pages in between the cells corner, just because it can be shorted. So now first of all we will add some masking tape to protect the short circuit, or you can say overlap to protect it from shorting in future, like this. we have to laminate all these, and then we add a battery protection sheet in between. Add it properly. So we have added it properly, and now what we are going to do, we are going to use these battery spacers. These are commonly used for lead acid batteries. So we will place this lining on this surface and another one like this, so that when we flip it, it will easily overlap. Then now let's flip it over. You can also add it like this, because we have both side rails. So just we have to flip it over and place it like this, and you can see this one. We have to flip it properly so that we can get a terminal outside, so that we can connect BMS on these terminals. So for that you have to push it in such a manner that it can come out. You can see now it is come out properly, and it is done. And now what we have to do, we have to first add this, and then we will tape it properly. We are done adding all the cells in series. You can see we have put this and flip it from here, then connected this and flip it from here, then connected these plus and flip it from here. So we have got all the stacks, and you can see here we have all the BMS connections, ports for all BMS connections. So here's our plus and the bottom is our minus. So let's connect a main wire and then add the BMS on it. First joint, second joint, third, and the 12-volt output. We have connected all our terminals and BMS. So let me guide how you can connect it. So you can see we have already told that we have created series from these, and it's the minus port. You can see we have taken 2.5 mm 3 wires from this end, from middle, and from the top, and these are coming from the series from this direction. So we have taken from these ends for proper discharging, and this goes to the battery minus terminal of the BMS, and the second one you can see it's a P minus. If you are able to see, then the port is P minus. Okay, and the P minus is our discharging port. Okay, and what we have already told you, that we have taken out the series joints from here. So we have just soldered from this one, this one, this one. So a 4S BMS is having 5 wires. So the black one goes to the minus, the second wire goes to the minus second series, third wire, you are able to see the third wire it is going to the third minus, or you can say plus, or third series, and here it's the third white wire which is going to the fourth series, and at last the red one, it is going to the plus terminal. Okay, and simultaneously, as we have done on the minus side, we have also connected 3 wires 2.5 mm to the plus port, and we have insulated it properly so that we can minimize the effects of any short circuit in the future. Just because we are making this pack for supposing that it will last about 10 to 12 years on the inverter, so we have created a lamination properly and taken out this port. Now what we are going to do, we will place the battery protection sheets like this, and here, and to this side as well, and apply 7 to 10 layers of this cellophane tape, and afterwards we will tape it with normal tape and try to make a whole cover with using of metal so that it can last up to 10 years in a perfect order.